some rest in the day, Rich, and hopefully the speakers will be here to do a bit more Q&A as well. But away you go, Nikan. Thank you.
Thank you so much, everyone. Right. Informed Solution. Informed Solution will be paving digital transformation journey for large enterprise using cross-cutting technologies and digital solutions. With the user's technology, we aim to build safer, cleaner, healthier, and greener environments. My name is Nikan Negaresh. I'm the technical lead consultant at Informed Solution. And today I'm here to take you through one of the journeys of transforming a monolith legacy solution and take it into a usable, scalable solution in an enterprise level organization. Right, in this session, we're going to be discussing about good old monolith versus microservice architectures, best practices, and what is actually needed, and what is the best practices, and what's the realistic way of doing it. And in this process, we're going to discuss about a fictitious and arbitrary solution that we imagined. And we're going to use that and try to convert that into a scalable solution. Obviously, we're going to be applying that in the context of a business. So we're going to talk about what a monolith architecture is, the challenges that the business is facing, how we started to modernizing that, and we're going to be talking about the scalability of that solution, as well as making the data and the services more modular and decoupled. And obviously followed by a Q&A. Will be a Q&A, no discussion. Joking. So the system that we are imagining is called Sapphire. Sapphire is a proper monolith solution that has been built throughout so many years, let's say 15 years, and it's that core solution that we see in the center of the screen, which is connected directly to a database. And as the time passes, the requirement of the business has started to grow, and the database has started to be consumed by for the analytical purposes, as well as marketing solution integration. You see, all integrated to the database. And the solution gradually started bigger and bigger and bigger, and started to serving so many external users, internal services, and external and internal users. So now there is an expectation for this solution to operate 24/7 and serving so many people and other industries. So this is an example of a standard multi-tier architecture which has been put in place around 15 years ago. So it started with a layer on top, which is the clients and web services, followed by an embedded security layer, some standard MVC model, an MVC, good old MVC architecture for the front end, which is going to be rendered through the back end and pushed into the front end and the browsers, followed by no REST services so far. And as you can see, all of the business domain is all grouped together into one single big monolith, followed by some capabilities which are shared across multiple components of this solution. Things like sending emails, storing documents, audit and log, and they're all using the same data storage and data access layer. So, as you see, it's quite a nice thing. It's quite structured. I hope it remains the same. This is the reality, a big ball of mud. What we see when we started to look into in depth into this solution, where we see that there is cross-communication across all aspects of this solution. Yes, it is hierarchical. Yes, it's multiple tiered, but all tiered are talking to each other and sharing different concepts and different contexts. And as you see, the database, for instance, there is everywhere, and it's all spread across all of the domains of the solution, as well as the user interface, which is going to be the big core monolith again inside of the same package. So as you can see, is quite a big challenge to make it more scalable. So we started to look at the challenges of this business and trying to understand what are the pain points. We started to divide the pain points in 3 different pillars. The first one is IT operation. There is no way to make this solution any more scalable. There is plenty of downtimes. There is trafficking. There is inconsistency in the operation depending on the traffic. There is no guarantee of the uptime. Services keep going down. So many memory usage. So many utilizations. And there is difficulty of maintenance. So for a simple bug fix, the whole business should go down. I have to mention that this is the business critical solution across the whole successful business. The next area is product management. So product management, there is so many challenges in this world to organize the release process, to align the release and features and planning for what features can go live at what stage, because all of the requirements are tangled together. So there is no isolation of releases, everything should go at once. And that will end up actually going through seasonal releases, so there is not so many CI/CD processes. In theory there is, but deliveries are not as common as it has to be. And the most painful part of this process was the development part. Basically, there is now, this solution has been started with the handful number of developers, but it's gradually started to grow, and is around 20 developers working in the same code base, raising various merge requests, and basically handling so many code conflicts. And the problem is that a single problem is going to be leaked and to the rest of the components. A simple example will be a simple data source bug can halt the whole solution because there is so many coupling across multiple aspects of this monolith solution. And obviously, the slow boots up time, it will take so much time for a developer to sit, wait, to boot up this application. Because there's so many lines of code needs to be compiled. As well as that, indexing that, and code testing. These are plenty of challenges that developers should be dealing with. Probably so many of us were facing these in the past. So we wanted to put a strategy in place to improve this and to convert this difficult situation into more manageable solution. However, we know a couple of facts. We cannot do it in one go. It's a massive solution. There is so many dependencies, so many product owners, so many stakeholders involved. It cannot go in one night. It cannot go in one go. So we have to do it in a manageable way. There's a couple of ideas that we know. We know microservices is great, but microservices is ideal, but it cannot be achieved at the same time. So it has to be done, and it has to go through a transition period. So we have to break it down into a transitional situation. The first thing that we started to agree was to make this existing monolith solution horizontally scalable. After that, we started at the same time, and after that we started to clarify the domain context and break them down and look at the realistic view of how these things can be modularized, followed by improving the developer experiences and aim for modularization. Now, of course, I have to mention that multiple times. First of all, this company is not Netflix. It doesn't have that much of budget. It doesn't have the capacity to try to rewrite everything from scratch and convert this into a greenfield solution and make everything in one go as microservice architecture in one go. So things has to be done in multiple stages. So the first stage that we started to look into was to keep monolith the same, however try to horizontally scale that. And the first stage was to introduce the load balancer or API gateway, or a layer that is going to receive the requests. Okay? And this is the first abstraction layer, which will allow us to later on replace the monolith into separated, isolated modules. But before achieving that, before enabling or allowing the load balancer to work, we have to make our monolith solution as stateless. So think about statelessness is the key. And the idea is that we have to the first stage is to externalize our state and make our monolith application worker. That means it's going to be a dumb box which just perform, and it doesn't hold any logic, it doesn't hold any state. And if we can achieve that, and if we could achieve that, as you see, the session management and caching layer is now out of these monoliths, and it would enable us to run n number of these monoliths, and it's starting to spread the traffic based on the entry points. As you can see, now we've got a group of monoliths just responding internal users, first level of isolations. We've got another set which are basically just serving the web services, and some even, they're just sitting in the background and just do the repetitive works, such as sending emails. And we've got n number of them. And this is the strategy that we call them server farms, and you have heard about it in the IIS in the past time. So moving forward, we started to look into modularization, but again, we have to keep the monolith running. We cannot completely unplug ourselves to monolith, so it has to be done in a gradual process. The first approach was to identify one or n number of these areas and domains and try to extract them. Rewriting is a bad thing. We don't want to rewrite. We want to move. We want to move the logic, move the data to another component, which can in the future be served separately. So as we go forward, the size of the monolith becomes smaller and smaller, while the number of our services and context are going to grow. So the first one that, let's say, we're going to be working on is going to be the account. So the account business logic is going to move to a separate package, and the user interface at the same time is going to be extracted. One of the pain points was to have a massive monolith user interface. Okay, that was not scalable. So adopting the micro front-end pattern was the enabler for us. And that means we will have a smaller number of single-page applications which can be written in multiple languages, and each of them will be serving depending on the context. As long as you keep the template the same, as long as you keep the structure the same, they all look the same, but they will be running on different servers potentially. So, and that was the plan. The other aspect was to try to split and extract the data layer. So we should stop the cross-communication between different entities of the database. Order database area should not talk to account. You have to split that. That will happen by splitting that and extracting that to a separate package. What we've done next was looking at the data. It is important to mention that the data is the piece that needs to be done at last. If you start jumping from the bottom and try to extract the data, there is a danger that your service layer needs to be rewritten. Because there is so many coupling around the data layer, around the querying, you have to make sure that you do the data extraction and data split at last. And obviously, if you remember that in one of the earlier slides, we had all of the data in one single database, which was a transactional database, and the analytical solution was looking at the same transactional database. It is key to split the transactional database with from the analytical database using some ETL or data transformation solutions in the middle, and make sure that all the data are using some sort of pipelines to go through the analytical database. In addition to that, CDC is one of the aspects that can help to replicate the data from the legacy solution to the OLAP database. So the key is keep the data duplicated in OLAP. Don't be afraid of data duplication. It's better than hitting your databases in your transactional database and impacting your service in operation. And summary. So the point of this process was mainly to show that it's not a big bang process, and it's more of what is possible at the time to try to achieve an operational business. We should think about business productivity. We should think about how we can keep going with minimum impact and not just thinking about microservice. We've been in so many environments that the goal was microservice design pattern implementation, and that ended up failing because everyone was so excited and passionate about let's build microservice. It's the buzzword. It's one of the most fashionable thing. Don't think about it. Think about what is realistically achievable in our environment. The next thing is enablement for development team for simplification of delivery. Do what is possible to make them productive and keep them productive and simplify the testing process. And of course, the microservice is ideal for that, but it's not always possible. And that's the example of this story that we've been through. However, if we do it right in a planned manner, we can definitely improve the business sustainability, and we can simplify the process of development and maintenance and keep the business going. And that should be the goal. Thank you so much. Any questions? Yes?
So there's a point where you split out a section of the domain, let's call it, from the monolith, and you split it out into its own microservice. That monolith, what's left in that monolith is core and truth to that. But in an ideal world, the UI or the user is hitting that directly. Can you speak a bit to that step between moving that interface so that it's not being hit by the monolith, but in fact being hit by?
Yeah, of course. Let me go through. Is this the layer?
Yeah.
Yes. So the load balancer layer is the key player, and it's got different routings. Okay, and you can identify that there is so many capabilities in your load balancer that is allowing you to route your request and traffic to different availability, let's say, groups or clusters. Okay, it depends where it's coming from and which URL are hitting. Okay, so if it, for instance, is calling s/web services, you can identify that.
I understand that, but the question is more, you almost certainly have a different sort of interface that points towards a user than you require internal communication.
That's right.
Within your VPN. So that there's a complex step there in terms of saying, now it's ready for users. What is that like, taking that step?
So there will be some steps behind this, obviously, but we are actually intentionally trying to reduce them and not showing them in here. Things like going through the firewalls, if you mean, or there is pre-routings before hitting this load balancer.
Yeah, I think where my head is really at is authorization. Whereas if it's the monolith hitting something else internally, there's no auth. And a lot of the time people
really good point. So in this situation, we talked about the session management. And session management is closely related to your authentication and authorization. Okay, and by delegating, so all of these monoliths are going to do the process of authentication and authorization. However, the result of authorization will not be stored in them. It will be stored in the cache or session manager. Okay, there's things that you can achieve there using the sticky sessions. I did briefly mention them, or making even a stateless. It depends really on the detail of your authentication process, or even you can completely pass your state into your front end. Okay, so it's really key to understand how your state management is going to handle. But the whole idea is to keep all of these monoliths as stateless as possible, just see them as workers. I hope I was able to answer your question. Any more questions? Yes?
With microservices, you go in a very long run, you have enough of services, so it will lead to a kind of traffic jam. Other than going into service mesh, do you have any other solution within the platform, or how do you deal with these things? For example, in JP Morgan, they had a kind of similar thing with the retail platform, so many services. Then we had another one fully jammed.
Can I ask in what way you consider something is jammed?
Passing there, you can have one person, another one, so there's a problem with routing.
Yes.
And also the API has so many Microservice calls and.
You're mentioning a really good point. So microservices, if they are not implemented in the correct way, they will end up another big ball of mud again. Okay, if they are not implemented. So I'm going to refer back to the previous actually discussion that was event sourcing. Okay, what we are not talking about now is post microservice implementation. Okay, because you're completely right. You can have a cross communication, traffic load, etc., after you build everything as microservices. That's why there's another session probably that we have to talk about how to build our microservices in a correct design pattern, architectured way. Okay, but yeah, 100%. This is the first step toward many other steps that to build a microservice architecture in a way that it can scale. So event sourcing was a good example that can resolve that problem that you mentioned, that it is stopping your services to halt, because event services do not talk to each other directly, and that's the goal to achieve. But we are kind of ended up in just converting that big monolith into some services that they can individually scale. Sorry?
What do you mean by event?
I would suggest you to answer that if you don't mind.
Say again, sir. I didn't back
What do we mean by event sourcing?
Event storming.
Event storming,
Event
yeah.
storming. What I just said.
Good one. Yeah, but I'm more than happy to have a chat with you after this session. Any other questions? Yes, please.
So this process has been the business driver, what the whole reason this whole project sort of was started was to allow the business to scale and be more responsive.
That's right.
Do you think that you've ended up at the same kind of architecture you would have started off with if you just did a greenfield project to build what this product ended up evolving to? Or is it still a product of a legacy monolith sort of thing? Is it sort of a microservices asterisk that had evolved from a monolith, if that makes sense?
Correct. That's right. This is completely different journey compared to what we want to build in a greenfield application. Okay, and that's why we call it's a journey. It's not going to be ended. We don't have at this stage. We don't say yes, we built it. Let's move on. It is still going to evolve. Probably each of those microservices are going to turn into some event-driven architectures, and it's going to evolve more and more. This is the first step of many further steps. Yeah. Please.
I'm going to assume that behind Sapphire there is a name which we can't talk about. Coming back to the previous talk, did you find that while implementing this solution, it had a material difference in the communication structures and the org structure within Sapphire? I'm just kind of calling it back to this talk about.
The idea is to keep the communications the same with minimum impact at this stage. Okay, but yes, it's unavoidable to keep all of them the same. There is already rethinking process to try to improve those as well. So yeah, definitely there will be some improvements in there. Yes, I think you had a question.
So I guess the next step that would have avoided traffic jams after this was because everything was talking to the same database. The next step would just be having each of those services have their own database that they could talk with to avoid that massive load going into that.
Yes.
Into the database service.
So as you see there, yeah, each of your services are now have their own databases, and even they don't just have the RDBMS. You'll see that some of them they do have even NoSQL databases. So you are moving toward an independence of technology. Whatever it fits for that team that are maintaining, let's say, auditing, they can choose their own database, they can choose their own programming language, and they can choose their own user interface. Because they are all following the same structure, the language is not going to be a problem.
Yeah, which goes into what Greg was saying before about trying to reduce cognitive load as well, where you can just make the problem area you're working with really small, so you can just focus on that without having to worry about anything else around where your problem is.
Correct. That's right. Yes?
How do you keep the business on that journey? Because obviously, you might do the first layer where you start to make some improvements, and then you've sort of got that, the load balancer layer, you sort of started to show that separation, and you might get to the next stage where you start to separate out the monoliths. How do you keep the business invested in that journey? It's not a quick thing, is it? At what point are there any challenges where they might say, that's enough now,
That's exactly a good point, and that's what we do at Informed Solution. We are not just building a solution for them, we are collaborating with them, we are partnering with them, and we are walking with them through this journey to make sure that they are actually receiving the digital solution that they demanding. It may take years to reach to a completely decoupled solution. Yes, definitely. It depends what they want, and it's actually based on what they want. And they are aware that, and we will make them aware that this is not a one-night job. This is not a 3-month project. Okay. Obviously, that's why we say the Informed Solution, we are working with enterprise and large businesses, and we work with them in this journey to achieve the digital transformation.
I guess Kevin Beck's mantra comes into this, where it's like, if you want to add a new feature, you've got to make the change easy. And it might be quite hard, but then once you've done all this change, it's quite easy to start adding additional features onto it. Whereas if you're trying to do, like, say, A/B testing on a monolithic application at the start, you'd have to run it in, like, the entire thing as a separate thing, even though it's doing most of the same thing, but then just routing to something else to do one small thing that's different.
That's absolutely right. Yeah, that's correct. Yeah, that's exactly the case.
Did you, on this specific step where you end up with effectively multiple copies of the monolith, obviously some work has gone into making it work in this way, but were there any unexpected side effects from running the monolith concurrently?
So the whole idea of making them stateless is to make sure that the business can continue its operation with minimum impact, okay, and the minimum code change in the business logic. Yes, there will be changes on the layers that they are performing the authentication, as you mentioned, or making these solutions stateless. But from the user perspective, everything should remain the same, and there shouldn't be any expectation of changing the behavior of the solution. Yeah, it will be a challenge. Achieving this itself is not easy, okay? Because we are talking about a 15-year-old solution, and converting that into this, it's a good challenge.
What went wrong?
Yes.
I think that's the underlying part of the question, isn't it? What problems did you encounter?
Yeah, there will be various challenges because sometimes it's really difficult to containerize, and I think somewhere I mentioned about the orchestration frameworks and containerization. Definitely there is challenges on versions, language compatibilities, dependencies, and it can go from anywhere, so case by case is different, but we try to actually envisage them and go through that process. Fix.
From personal experience on the, particularly on the background workers, you can end up with, or in my experience, there have been undesired side effects from running specific background tasks simultaneously. That we ended up being in the software because we didn't understand it and rebuilding that specific area because it was causing so much of a undefined level of behaviour. So it was a case of, we're not really interested in running this part of the monolith. The tasks are relatively simple. We can pull the tasks out themselves. But yeah, we had fun there.
Yeah, definitely. I can.
When looking at this, you've effectively got 6 instances of the monolith, and so obviously you're separating that functionality. So that suggests that your database scaling wasn't the problem. You could vertically scale that. I don't understand why you wouldn't just run 6 instances of the monolith if you had an issue with horizontal scale or like the code running efficiently. I don't quite see what this gains you putting this reverse proxy in when you could just, like I say, do that, because it sounds like you have an instance issue as opposed to a code efficiency issue as opposed to a database problem.
Well, if you remember in one of these slides, one of the concerns of the business was the uptime, release cycle, and traffic load. Okay, this structure is improving those areas. For release process, you can keep the application running 24/7 and gradually upgrade these. Okay. The other area is you can try to do A/B testings and blue-green testing, etc., etc. So try to route the users to specific sets of boxes or instances, let's say.
Yeah.
So that's one of them. And definitely vertically versus horizontally scaling is another aspect that we were hitting the server limits in terms of the memory and CPU usage. And by doing this, you can reduce the fraction of their usage massively, because we can envisage that the external calls are more in terms of the traffic capacity, and we could say, okay, these boxes can have bigger sizes compared to things that, let's say, are being done by internal users. So you will have flexibility of configuring your cluster, if you call it.
But when you came to release this, I imagine this would be one reader.
Correct.
So wouldn't you need to release that across all 6 instances?
You can do it gradually, and that's the beauty you can get. You can keep the previous instances running and gradually going through them, both horizontally and horizontally and vertically. That means you can go inside of them and just upgrade 1 or 2 of the instances in each group, or you can say, okay, no, my strategy is to just upgrade the external use cases, okay, because and buy some time to test those until the new features are going to get ready and released. So you have more control. It's not about buying time and controlling this approach.
You'd be doing the blue-green
Yes,
deployment
that's
across
right.
multiple instances.
Correct. Yes.
One of the other problems is if you have a runtime error in microservices, and if you have microservice chain, how do you avoid still going with the event storm event storming and try to avoid chains as possible as you can, or do we have any other ways to manage runtime errors? Because if you have a chain, it's very difficult to track the location of the error.
Really good point. That's one of the common problems, and after these stages there is some operation investments that are needed, and one of them is about monitoring and application performance monitoring, and working toward achieving a distributed transaction management and distributed tracing solutions to understand how the chain is working and operating, what are the bottlenecks there, and where you can actually pinpoint the problems. So there is definitely solutions that as part of the microservice integration, there will be an investment on APM and performance monitoring of your cluster and your microservice architecture.
Sorry to jump in again. I'm just going to call that a wrap on the presentation because I'm mindful of time. But thank you, Nikan.
So much.